We'll start in 5 minutes. You can close the door. Great. Good morning. So on behalf on behalf of the Department of Computer Science, IISc, it gives me great pleasure and excitement to welcome all of you to the Art of Computing workshop. We are sort of very looking forward to a great set of line of speakers and a very uniquely themed event. It's not a, I mean, it's a workshop that will not only highlight the technical depth and engineering impact of computer science, but it also try to bring out the creative avenues of this beautiful domain that we love to work in. We have a extremely sort of competent lineup of speakers. We hope that over the weekend you'll experience that the creative canvas of computer science is as broad as the blue skies of Bangalore, which you have left behind to sit over a weekend in this auditorium. The workshop was conceived by Arindam Khan, my colleague from the Department of Computer Science and Automation at IISc, and Arga Manna from IIT Gandhinagar. It is made possible by the contribution of 13 amazing speakers who you'll sort of get to interact with, listen to today and tomorrow. The workshop is being supported by a generous grant by Walmart. It's a CSR grant, so you will see Walmart representatives. So please, during coffee breaks, during lunches, not during talks, do thank them in person. Do also thank in addition to the Walmart sponsors, do also thank the student volunteers who have been helping us organize this, the speakers, and certainly the two lead organizers. With that, let me also point two quick logistic issues. Please do hold on to these name cards if you're planning to attend tomorrow and if you're planning to consume lunch. The lunch which will be served on this side of the auditorium. So if you go back, lunch and coffee is there. We hope you enjoy it almost as much as the talks. Otherwise, you will see volunteers who are wearing black t-shirts with the workshop name and logo. Feel free to contact them if you have any sort of questions to ask, doubts to clear, or there any logistic help that we can offer you. With that, let me start. Again, reminder, please do hold on to it. We are not going to issue this again tomorrow if you have registered. And with that, let me start the first session of the workshop. And it gives me absolute honor to introduce the first speaker of the session and the first speaker of the day, Professor Narhari. Professor Narhari is a preeminent authority on game theory, mechanism design, their application, connections to fields like AI, and their use in very socially sensitive, socially relevant contexts such as agriculture. His talk today will touch upon these themes. Professor Narhari is a fellow of IEEE, fellow of Indian National Science Academy, Indian Academy of Sciences, Indian National Academy of Engineering, National Academy of Sciences. So every important academic body in India. He's a recipient of the J.C. Bose National Fellowship and an IISc Alumni Award for Research Excellence. His widely used textbook on game theory sets the standard for technical exposition. So it's very likely that if you're taking a course on game theory in India, you're using his textbook, you're solving questions from that book, and you're being taught by someone who actually is from the academic tree that starts at Professor Narhari. You can think of this academic tree as a Bodhi tree that's rooted deeply at CSA IISc, but a tree whose branches span across the world and certainly across India. It's a nurturing tree. It has nurtured young colleagues like me, has nurtured generations of students, inspired generations of computer science thinkers, and I'm sure you'll see sparks of this sort of excitement about a field in his talk. We could not have asked for a better speaker to start the event, and with that, please join me in welcoming Professor Narhari. So, just a quick note, first for 10 odd minutes, Professor Narhari will talk about the Department of Computer Science and Automation, the programs we have, and then he will move on to his technical talk, which is going to be AI for agriculture.
Thank you, Siddharth, for a very, 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 very kind introduction. And good morning. Did you not have any breakfast? Good morning. Yeah. Thank you. I think I consider it a privilege to be talking to the new generation here. You are going to be the leaders of India in the years to come. So it's a unique privilege for me to be talking to you about a department which has shaped the course of computer science in India for over 50 years now, and that is the Department of Computer Science and Automation. So I'll give you a little introduction to the Department of Computer Science and Automation, and that should set the stage for this workshop. The department itself is 50 plus years. 2019-20 we celebrated our golden jubilee. It has been a fascinating journey, started in 1969 by Professor Dikshitalu, who was the convener of the automation unit at the Indian Institute of Science. Then in 1971, we formed a department which was called as School of Automation, and Professor I.G. Sharma became the inaugural chair of the School of Automation. And CSA is a brand. It is not computer science and engineering, but it is computer science and automation. Very, very few departments in the world will be called as computer science and automation. And we started a School of Automation, and we have consciously not dropped automation from our nomenclature. And currently, as you know, automation is on the upswing, and we will continue to keep this nomenclature CSA in the future also. As of now, CSA is top-ranked computer science department in India. If you go to csrankings.org, this is the only department in India which is in the top 100. It has global presence in all international research forums, meaning all the flagship conference and journal venues. And the graduates of CSA, if all of you join CSA for your masters and PhD programs, the graduates are highly sought after nationally and internationally by the academia and industry. CSA, in addition to its core areas like theoretical computer science, computer systems, and artificial intelligence and machine learning, is also very intensely involved in cross-disciplinary initiatives in the institute. For example, it's a very important part of the Kotak IISc AI/ML Center at the institute. It is also an important part of the Power Grid Center of Excellence in Cybersecurity, Robert Bosch Center for Cyber Physical Systems, then the AI and Robotics Technology Park, or the ART Park at IISc. It's also a part of the Brain Computation and Data BCD initiative at the institute. CSA pursues research and innovation in a wide spectrum of areas. These are some research themes. For example, there's a very active group working on fairness in artificial intelligence and machine learning, stochastic control, reinforcement learning, NLP, AI/ML systems, GPUs and accelerators, database query optimization, formal verification, cloud and IoT security. Then in theoretical computer science, circuit complexity, multi-party computation, zero knowledge protocols, cryptanalysis, and so on. These are only some of the more important research themes which are pursued as a part of the wide spectrum of research themes at the department. In terms of degree programs, some of you, most of you would be interested. We have a very thriving, very lively PhD program. We have an MTech by Research program, which is a 2-year mini PhD program. Then we have an MTech by Coursework program, which is again a 2-year program. Then we also have an exclusive MTech in AI program, which is offered in addition to CSA department by 3 other departments. It's a divisional level initiative at the institute. And then CSA also happens to be a core participant in the newly introduced BTech in Maths and Computing program. In terms of faculty, we have 29 faculty with us. And you can see the wide repertoire of universities from which all of these faculty members are coming from. Their PhD is from all leading universities in the world. And in terms of recognition, you can see that the faculty members of the department are widely decorated. More importantly, I think students. CSA students are among the very best in the country, and they match the best, I would say, at the global level. Currently, we have a very healthy gender ratio. We would like to make it 50-50 in course of time. You can see that we have 91 PhD students, and we have 181 master students and 21 MTech research students. And I would say that students in CSA are perhaps even more accomplished than the faculty. In terms of the recognitions that they have got, PhD and MTech graduates of the department have got placed in some of the leading academic departments and industrial research labs worldwide. And you can see the list of universities here. A very important fact that I would like your attention on is that over 60, in fact this number is growing, and I think currently this number is almost like 100 of our alumni, meaning our PhD students and the MTech graduates from CSA department. They are faculty at leading universities worldwide. We have our alumni who are faculty members at Harvard University, University of Texas Austin, CMU, Rutgers, Purdue, and so on. And nationally, IIT Bombay, IIT Delhi, and all the leading IITs. In fact, currently, two IITs, IIT Gandhinagar and IIT Jammu, the directors of these two IITs happen to be alumni of the department. So CSA is represented in almost all the IITs. I would say that about 50 of the alumni of CSA are currently faculty members in Indian Institutes of Technology. And in terms of student awards, ACM India PhD Dissertation Award is the most prestigious award for a PhD thesis in computer science in India. And IISc is regularly represented in these in this forum. Palash Dey was the winner in 2017. Shikhar Vasisht was the winner in 2021, and Supravot and Shruti Shekhar they got the honorable mention in 2022 and 23. And the students here receive highly competitive industrial fellowships from Google, IBM, TCS, Infosys. Currently, 7 of the PhD students at the department have Google fellowships. And then more than 20 of the students have the prestigious Prime Minister's Research Fellowship, PMRF Fellowship. Then in terms of industry impact, almost every leading industrial research corporation in Bangalore has presence in the department. And this very workshop, which is very generously funded by Walmart Labs, also has many alumni of CSA working in Walmart Labs. And you name a global corporation, they have a presence in the CSA department. And in addition to the industry impact that CSA has been having in the Bangalore ecosystem, it turns out that CSA in some sense incubated Wipro Information Technology. The early days, the first 2 years of Wipro were spent in a lab in the computer science and automation department. So in some sense, Wipro Information Technology was born in the department of CSA. And Strand Life Sciences, which is now a globally known company in the area of bioinformatics, was also incubated at CSA. In fact, 4 faculty members, Professor Vijay Chandru, Professor Ramesh Hariharan, Professor Vinay, and Professor Swami Manohar, who were actually faculty members in the department, were the key for setting up Strand Life Sciences. And then we have MIMIC, where Professor Vijay Natarajan, one of our current faculty members, plays an important role, and Polymage Labs, which is the brainchild of Professor Uday Kumar Reddy, who also happens to be a current faculty member in the department. So I think that's a very brief glimpse about CSA, and CSA is an exciting place, and you would find over the next 2 days that your motivation to join CSA will have an exponential rise. And the CSA department is about 1.5 kilometers from here, maybe slightly less. When you have time during these 2 days, take a look at the CSA department and take a look at the IISc campus, and I'm sure you will fall in love with IISc, and you will also fall in love with CSA, and we are hoping that all of you will join CSA and become as great as some of the students who have graduated out of CSA. So with this, I would like to close my presentation on CSA. We'll be happy to take any quick questions that you may have about the Department of CSA.
There are mics around, so you don't have to speak loudly. There is volunteers who have mics here, so please feel free to flag them and ask questions if you have.
Is my sound okay? Is the audio fine? Let me move on to my other talk today, which I call as algorithmic agriculture. And I hope this talk will whet the appetite of some of you who would be interested in applying the art of computing or algorithms or artificial intelligence or machine learning to an area which actually touches billions, almost a billion of people in India. Okay, so let me start with the motivation for this area. If you look at the Indian agriculture sector, it is the largest sector in India, which contributes approximately 18% to the gross domestic product of the country directly, and about 15%, about 33% of the gross domestic product in India, the contribution actually comes from agriculture. This is one area which all of you would be familiar with. It actually employs approximately 50% of labor force directly and is the lifeline for much of India's population. This is another fact which is extremely well known. This area has excellent prospects for export revenue. India is one of the leading producers of agricultural products, and already exports worth 41 billion US dollars in 2021. So in some sense, this is the current status of the agricultural sector in India. But there is an unfortunate dichotomy in Indian agriculture. What is this? India happens to be the second largest food producer in the world. This is a fact which is very well known. However, at the same time, it is also 71st in Global Food Security Index. India happens to be the second largest producer of rice and wheat. However, global leaders like Israel, they produce 10 times higher yield than India. So imagine what will happen if India also starts producing 10 times higher yield. Then India produces 1 billion tons of food commodities per year. However, if you look at the global hunger index, India is actually a lowly 101st in the global hunger index. So there is this unfortunate situation which is plaguing the agriculture sector in India. And then if you look at this section called the small and marginal farmers. When you say small and marginal farmers, you are talking about farmers who have less than 5 acres of land. All of you understand what an acre of land will mean. And it turns out that 125 million, which is almost like 88% of 145 million farmers in India, happen to be small and marginal farmers. Now, these small and marginal farmers actually support 600 millions or 60 crore family members at something like 4.9 members per family. Then these families are also earning less than 5,000 rupees per month per family of 4.9 members. You can imagine that the average monthly income of these farmers is something like 5,000 rupees. So if you look at the agricultural crop life cycle, there are many stages to it. There are essentially 3 main stages. One is the crop planning and input procurement stage. This is when you plan the crops and then you will actually try to source or you will try to procure all the inputs which are required for you to grow. Then you have the farming operations where you will actually do the growing of the crops. And finally, you will harvest the crops and then there is a post-harvest operation. If you look at crop planning and input procurement, what are some typical decisions that you take? What and when to grow? This is one decision that every farmer is faced with at the beginning of any crop cycle, before the beginning of the season. What to grow and how much to grow and when to grow which crop. Then seeds, fertilizers and pesticides. If you want to grow something, you will certainly need seeds, you will need fertilizers and you will need pesticides. So how do I procure the so-called agricultural inputs? Then you will also need farm equipment, high-tech equipment. Then of course you need money, so insurance and credit. You can see before the farmer decides to grow something, these are some things that the farmer is already worried about. And then when the farmer starts the operations, you have all these uncertainties. Weather is uncertain, irrigation facilities are uncertain, and pest control is something that the farmer is always faced with. And one has to do a continuous monitoring on an hourly or daily basis is what the farmer has to do. So the farming happens. It could be 3 months, it could be 6 months, depending on the crop. And then when everything is done, when the crop has matured, and then you do the harvest. Now the question that the farmer is faced with is when to harvest. That's going to be a very important decision. We'll see sometime soon why that's going to be a very crucial decision for the farmer. Now, which market to sell the produce? so has produced, let's say, onions or groundnuts. Now the next question is, which is the best market where this can be sold? Then storage and logistics, because many of these commodities could be perishable. So storage and logistics will also play an important role. And then finally, food processing issues are also there. So in some sense, these are the various activities and tasks that the farmer is involved in the life cycle of any crop. And you would see that there are uncertainties of various kinds that the farmer is faced with. And so how do you actually take care of all these uncertainties is a huge problem for the farmer. So if we ask the question, is all well with the small and marginal farmer in the Indian context, the answer obviously is no. So can we do something to improve the situation? I think this was the motivation for the work that we undertook. So is there something that we can do? Is there something that we can do as computer science people, as technology people, to help small and marginal farmers whose number is something like 12.5 crores in the Indian context, and almost like 60 crore population is dependent on these 12.5 crore small and marginal farmers. And even a simple improvement that you are able to do can have a huge impact on this particular sector. I think this was the driving motivation for us to try to do something for small and marginal farmers. Now, how can that be done? So, algorithms for decision making under uncertainty. We have seen that farmers are faced with uncertainties of every kind during the entire life cycle of a crop. Now, is there something that we can do to reduce this uncertainty, or is there something that we can do to enable the farmer to be able to tackle this uncertainty in the most effective fashion? And what kind of algorithms will be able to help? And can we deploy some of these algorithms to really enable and empower our small and marginal farmers? This is an important question that any one of us can ask. So in some sense, this was the motivation for getting into an area which was in some sense very risky for a computer science person to undertake. Now, computer science as a discipline and algorithms as a powerful tool that computer science gives you, they are ubiquitous. They have applications everywhere. Their applications pervade almost every single aspect of human life. And agriculture certainly is one of them. But the question is, how can we really make algorithms work? How can we really make computing and computer science make a difference to agriculture? So with this as the motivation, I think we had an opportunity knocking on our door sometime in 2020. All of you would be knowing about the National Bank for Agriculture and Rural Development. It's called NABARD. So through a good friend called Mr. Rama, I got introduced to Dr. P.V.S. Suryakumar, who happens to be Deputy Managing Director at NABARD. And during a conversation with Dr. Suryakumar, he basically convinced that it is possible to do something for Indian agriculture from a computer science department, and using algorithms, and using, of course, artificial intelligence and machine learning. So basically Dr. Suryakumar said, why don't you make a proposal to NABARD, and then we will see what can be done from NABARD. So what I basically did was to prepare a presentation that was attended by the NABARD scientists and also the NABARD officers. And at the end of a half an hour presentation, they were thoroughly unimpressed. The feeling was that what can a computer science professor do for Indian agriculture? they had misgivings of various kinds. I had a fairly tough Q&A session where they started asking all kinds of questions, right? So I tried my very best to answer some of these questions, but I think they were not convinced. And this is something that you will encounter when you start working in areas like agriculture. I'll probably tell you a few more things that happened while working in this area. So that was my first experience of giving a talk on how computer science and algorithms will be able to help an area like Indian agriculture. But Dr. Surya Kumar did not give up. But for Dr. Surya Kumar, this project would not have happened. He did not give up. He said, Professor Narahari, perhaps they did not understand the futuristic nature of what you were trying to do. Next week, we have a board meeting, and why don't you give a talk to the board meeting next week and try to convince your own way the board members of NABARD, right? So I think that was the opportunity that I got. So next 1 week, I think I worked like a grad student, because I had to impress managers there. I had to impress the board members. So I really went into the details and then started making a presentation. I gave a rehearsal of this presentation to some of my students who were also equally unimpressed. But then I tried to improve the presentation, and finally I think I gave a presentation to the board which was supposed to be for 15 minutes. And the Q&A was supposed to be for 5 minutes. See, sometimes luck is very important. If you don't have luck, if you have talent but you don't have luck, things will not work out. I think that happened to be one of my lucky days. So, and the preparation that I had done also really helped. So when I made this presentation, I think they were impressed. In fact, one of the board members was clean bowled. So he said, here is a professor, I think it is not bad. It's not a bad idea to invest a certain amount of money on this professor. So then I think at the end of a very lively Q&A session, then I think the NABARD management decided that they can give a project to a computer science professor to do something for Indian agriculture. And that's how I think this project came about. The project was sanctioned within 1 month time. Now I had my next challenge. My next challenge was how to recruit students for a project in agriculture in a core computer science department. Not very easy, not very easy. So I floated some MTech projects in agriculture. Nobody would come forward. Nobody came forward. Finally, I think, see, if you cannot convince anybody, you have to only convince your PhD students, because your PhD student is in something you are captive, right? Everything for a PhD student will depend on the professor. So here was a PhD student called Mayank Ratan Bhardwaj, who is sitting right there. And so I think I was able to convince him. I did not force him. You can talk to him offline. So I did not force him, but I think he was convinced. He did have some agriculture background, and he thought he can try out agriculture for his PhD thesis, right? So this was my first breakthrough. My second breakthrough was that there was one Inavamshi who had just completed his master's from New York University and then came here, and he was looking for a project in social good. And a project in agriculture qualifies in the best possible way for a project in social good. So I think he also was bought into it. He said agriculture is one area where we can really do something. So he was bought into it. And then I still did not have any students. One student joined. His name is Someshwar. Hats off to him, because against all the trends in the computer science department, he was the only person who said, sir, I will come and work with you. So he started his MTech project with me. So then the next year came where the NABARD project had already been given and I had to find some more students. So that's my next challenge. Mayank is there, Inavamshi is there, Someshwar is there, nobody else is there. There was one Arun. So what I did was, I said, I will float some projects in agriculture, but now I will put deep learning before every title of this MTech project. So I floated 6 projects, deep learning based crop price prediction, deep learning based crop recommendation, deep learning based procurement, everything, right? Deep learning was there as a keyword for all the projects. And then it turned out that as many as 26 MTech project students wanted to work with me on these projects. It was not because of agriculture, it was because of deep learning, right? Gate number 1, Jaydeep, he wanted to work with me. All India rank number 2, Gate, Kishan, he wanted to work with me. And then I had 6 MTech project students working with me, and that is how I think the team has grown to this. So over the last 3 years' time, I have had the benefit of working with some of the best students, and some of them are here. And I also had interns coming from various colleges in Bangalore. I must tell you that our group actually has hosted several interns from Bangalore colleges. And I can also tell you that some of them have done excellent work as a part of this project. And you can see the army of students. In fact, I have not even put the pictures of the current set of 6 students who are working with me for their MTech projects, right? So I think what has happened is that in the last 3 years, we have been able to bring up this project called the Rama project. And Rama also has an interesting acronym. G for game theory, because I teach game theory, I work in game theory, and then random processes, because I said everything about agriculture is uncertain. Then how can I not have artificial intelligence, AI? Then machine learning for agriculture. That makes the acronym GRAMA. And as a part of the GRAMA project, all that we have done is to design algorithms of various kinds for different important problems in agriculture. And so these are the 6, in some sense, these are the 6 components of the GRAMA project. I'll briefly explain each one of these to you now, and then I will take you through the details of maybe a couple of these projects. The first one is Crop S. Crop S is a crop planning system which will help government authorities and planners to decide what kind of crops the farmers should be growing in any given crop season. It could be a Kharif season, it could be a Rabi season. And nowadays the Indian government actually is in favor of district-wise planning of agricultural crops. So what they are trying to do is, for every district in the country, they are trying to identify a certain portfolio of crops, certain principal crops that must be grown in the district. So now the next question would be, right, which portfolio of crops should be grown in which district? For example, Karnataka state has 30 districts, and in each one of these districts, a wide variety of crops are currently being grown, but is that the optimal mix of crops being grown in these districts is a question that we have to ask, right? It turns out that there are much better ways of planning out the crops, and what we have done using fairly simple optimization, combinatorial optimization formulations, how the current portfolios of crops among the different districts can be transformed into different portfolios which will actually maximize the benefits to the farmers and also produce much higher revenue for the government. So this is the crop planning system. So then we have a module called Prepare. Prepare stands for Price Prediction for Agriculture. So this is one module that we are going to discuss in some detail. How do you predict the prices of agricultural crops, let's say 1 week in advance, 2 weeks in advance, or even 1 month in advance? And this information can be extremely useful to agricultural farmers, because that will tell them when to harvest their crops. That will also tell them, how they should manage their crops. It will also tell the government what kind of facilities and warehouses they should be ready with when the crop is actually harvested and so on. It's a very difficult problem. In fact, many of these problems that are there in agriculture happen to be grand challenge problems. These are problems which so many different people have attempted over decades, over centuries, and still there are no satisfactory solutions to these problems. So this is where algorithms, very smart algorithms, very innovative algorithms, and the art of designing algorithms will come into play in coming up with algorithms which will do much better. Then we have this ACRE, which is Agricultural Crop Recommendation. A farmer before the beginning of the season has to decide which crop or which crops he has to grow in the land that he has. So if there is a scientific advisory to the farmers telling them this is the exact combination of crops which will be good for you, for the soil conditions, for the weather conditions, and for marketing considerations and so on, the farmer will be really benefited. Then we have Prosper, which is basically a marketplace for agricultural crops. And one of the most important difficulties that farmers have, they're ready with their agricultural produce, but they don't know where to sell it. They do not know at what price they should be selling it. They do not know which markets will give them the best possible prices. So Prosper is basically a marketplace which will enable them to maximize their revenues. And then we have Promise, which is basically helping the farmers in order to decide about their agricultural inputs like seeds, fertilizers, and pesticides, and how they will be able to procure some of these at in a cost-effective way. And finally, what we are trying to do is to build an AI/ML pipeline for agriculture in the lab. The kind of data analytics that you do in agriculture tend to be a little different from other verticals or other domains. So AgriVahan is an AI/ML pipeline which over a period of time we would like AgriVahan to be downloadable by different research groups or colleges working in agriculture related problems, and they will be able to kickstart their own work in agriculture using this platform. I think in some sense this is the summary of the Rama project that we have been doing over the last 3 years or so. I must say that we have made only modest progress. There is a lot that needs to be done. If there are any questions at this point, I would like to take some questions before I get into the details of at least one of these modules. Any questions? Yes.
Have you actually tried to implement this, one of these projects in real life? Because most of the times farmers are not that much tech savvy to get accustomed to such solutions.
Yeah. Absolutely, that is the most important part of any project in agriculture. So deployment of, designing algorithms is the easy part, but making mobile apps and being able to deploy them on the field, right, in realistic conditions is actually the more important part. And fortunately, Bharat Electronics Limited is teaming up with us, and I'm going to describe one of those projects to you immediately. The Promise project is something that we are actually able to deploy on the field with the help of Bharat Electronics Limited. At some point in the talk, I'm also going to talk about the implementation challenges, the practical issues which are involved in deploying some of these. So deploying is much more important than actual design of algorithms. But algorithms are also important because these are the ones which will make those deployments possible, right? Yes.
Sir, so I've heard that millets are like a low water taking and a bit easier to grow crops. So are they also in your like crop planning system?
Oh, okay, millet. You're talking about millets.
Yes, sir.
Okay, do you like millets?
Yes, sir.
Okay, so absolutely, I think the crop planning system will take into account any number of crops, right?
Okay.
So we have results for let's say up to some 20 crops or so, but the formulation, the mathematical formulation that we have can handle any number of crops, right? Of course, the complexity
Yes, sir,
of
like
solving
I-
such a problem will increase with time. Yes.
Yes, sir, like the mathematical formulation can, but in actual, like in the practice, do you like consider all the crops, like millets?
Okay, so in practice, one has to consider all the crops, right? When the government tries to do crop planning for different districts in the state, they have to do a very detailed planning, and the number of crops that you are talking about is in terms of hundreds of crops, right? So, but for proof of concept, we have been able to do for 20 crops, but there is no reason why, right? The same thing cannot be scaled up to much more number of crops. Yes.
Okay, sir, thank you.
Yeah, so what I'm saying is, right, let's say assume there's a particular region where a certain crop is more profitable than other crops, but the optimal crop is something else which comes up on the system. So how would you tackle that?
Okay, crop planning takes into account all of these factors. It takes into account, which markets are more profitable for which crops, what is the distance of those markets from the current location, transportation charges, warehouse charges, soil conditions, weather conditions, exports, imports, everything, right? It's a very interesting mathematical programming formulation, right? Yeah. I think there are many more questions. Siddharth, how are we doing on time? 20 more minutes. Yeah, because I would like to present details of at least one of these components because people are interested in deployment. Yeah. Maybe just one last question I'll take and then I'll move on.
We can have the Q&A at the end of the talk, and of course during coffee breaks.
Sir, my name is Ved. I'd like to ask this question. So most of agricultural processes, all of them are dependent on weather. So with climate change and weather patterns being so unpredictable, right now in Bangalore we have the El
Yeah,
Nino effect.
so
How do you account for that exactly?
exactly. So uncertainty handling is perhaps the most important part of the algorithms that we are designing. That's
Right.
why I said these are algorithms for decision making under uncertainty, right? So I think all the algorithms do take into account these, and in fact in Rama R actually stands for random processes. So it's an integral
How
part
accurate
of
can
all
they
the
be?
formulations. Pardon?
How accurate can they be in such randomness?
See, that's where availability of data becomes very important. So if you have extensive amount of data available to you, you can actually fit probability distributions to this data, and that is how you will be able to take care of these in your formulations.
Right. Thank you, sir.
Okay. Okay, so let me move on to one of these components, which is promise. The reason why I would like to present this to you is because this is something that we are able to successfully deploy on the field. So promise is procurement mechanisms for agricultural inputs and services. So what do I mean here? So the way in which we have been able to do promise is through the notion of farmer collectives, farmer producer organizations. NABARD as an organization has championed this notion of farmer producer organizations. What is an FPO? There are actually 60,000 FPOs in the country right now. An FPO actually exploits economies of scale And what an FPO basically comprises is actually a collection of a large number of farmers. For example, hundreds and thousands of farmers can come together and form a cooperative. All of you would be familiar with the milk cooperatives in Gujarat under Amul, which are so successful. The question is, how can we make the notion of cooperative successful, even for agriculture in general? Now it turns out that an FPO is something that we can exploit in procurement operations in the following way. So in order to understand this problem, what we did was we went to a place called Rajkhatta from the Doddaballapur Taluk, 40 kilometers from Bangalore, and we spent a full day there. There are 1,000 farmers who are associated with this FPO, and we try to understand how the input operations and output operations are facilitated by this cooperative. We also we found that this particular FPO helps the farmers with procurement. When we talk about procurement in agriculture, we are talking about procurement of agricultural crop seeds, fertilizers and pesticides, which are all very crucial for agri operations. Now we also went to not only Rajkhatta but also another FPO called Anekal, and the observations that we had in our field visits are the following. Farmers face challenges on the input side and also on the output side. When I say output side, marketing and selling. Now intermediaries or brokers or middlemen hold sway by offering credit and market reach to the farmers. So what the middlemen basically do is, they will give the farmers credit. Getting cash and getting credit is the most important thing for small and marginal farmers. Here are middlemen who actually offer them credit and then get 40 to 50% margins on these agri inputs. And then having given the credit, what happens is when the farmer is ready with the agricultural produce, the same middlemen will come into picture and they would have captured these farmers, and they again get another 40 to 50% margins when they are actually selling the agricultural produce of the farmers. Now it also turns out that FPOs themselves are not well funded. They lack the support to make a significant difference. But what we observed was that with the right kind of resources, support from the government and technology adoption, FPOs actually can become game changers for agricultural operations. So what we did was to do a study of how seeds are procured, how fertilizers are procured, how pesticides are procured, and how high-tech equipment is procured. And as I said, credit plays a very important role. And here is a quote from a typical farmer. If inputs are substandard or fake, we have to go through a minimum of 2 years of suffering due to debt. Therefore, in addition to the good rains, the quality of inputs we buy decides our farm income season after seasons. This explains to you the importance of agricultural inputs. So our idea was somewhat simple. We wanted to design a procurement marketplace for inputs and services. We have the farmers here, and for example, the FPOs at Rajkhatta and Anekal had 1,000 farmers associated with them. So we have the FPO here, and we have these agricultural input vendors or the suppliers. So the idea is the following, very simple idea. Design an algorithm and develop a mobile app for the FPO to aggregate the input requirement of all farmers attached to the FPO. So each farmer has a certain requirement for seeds, fertilizers and pesticides. This simple mobile app will get this requirement from every individual farmer, and the FPO will actually aggregate all of these requirements and put them into various buckets. Each bucket may, for example, consist of, one bucket may correspond to 1 ton of some seeds. Another could correspond to 2 tons of a particular fertilizer. So you can see, you will get aggregated requirements for all these agri inputs. And now what do? The FPO now engages with suppliers who can now supply things in bulk. You do a bulk procurement of fertilizers, you do a bulk procurement of seeds, and you do a bulk procurement of pesticides, and then having procured them at affordable cost, you now distribute it back to the farmers. This is the simple idea. There is a mobile app involved here. You have to design the mobile app. There is an algorithm involved here. The algorithm involved here is in trying to minimize the total cost of procurement from these various vendors. And what kind of mechanisms can be used in order to do this procurement? We found that simple, easy to understand auction mechanisms can be understood very well by the vendors. So in order to see whether this is acceptable to the vendors, we actually went to a place called New Tarugupet in Bangalore. That is where most of the agricultural vendors are there. We individually talked to these vendors. We explained to them this idea, and we explained to them the idea of an auction, and we explained the end-to-end workflow of the procurement system, and we found that some of them were comfortable. Not all of them were comfortable. Some of them were indeed comfortable. Okay. So I think this was the main idea which we wanted to implement, and I will skip some of these details, but I will talk about the core algorithm that was involved in bringing up this particular application. This core algorithm was a procurement auction. Here is the FPO. The FPO may require, let's say, in bulk, 2,000 packets of A, 1,000 of B, 1,000 of C, 1,000 of D, and 2,500 of E. Right? And you have all these various suppliers. So you now do an auction, and in this particular case, this auction is a volume discount auction. And in this volume discount auction will then tell you what is the allocation of different things that you want to procure to the different vendors to minimize the total cost of procurement for you. And that turns out to be an interesting mathematical programming problem. And so it also turns out to be an interesting mechanism design problem. So you can see that you are now, in order to design this algorithm, you are actually formulating and solving an optimization problem. You are now looking at how you can design an auction, and the design of an auction pretty much depends on game theory. And it turns out that these are the various properties that you would like this mechanism to satisfy. I do not want to get into the details of these, right? But incentive compatibility is something which will make the vendors to bid very honestly. Individual rationality is something that will ensure that the vendors do not lose any money. Social welfare maximization is something which will maximize the utility of all the stakeholders who are involved in this procurement operation. Cost minimization extremely important because you want to minimize the total cost of procurement. And then fairness of allocation. If you have multiple vendors, how do you ensure that all the vendors will get an equal chance, is fairness of allocation. And then you have business constraints, because you don't want to give the business to only one vendor. You don't want to give the business to too many vendors, right? So these are some business constraints. So now you want to design an algorithm which will actually satisfy all of these properties at the same time. And game theory will tell you that it's impossible to design a mechanism which will satisfy all these properties. So when you cannot solve a problem, what do you do nowadays? All that you will do is collect some data and use deep learning. That's all you will do. You will design a deep learning algorithm and hope that the deep learning algorithm will solve the problem for you. And it turned out that in this particular case, here was an impossibility of designing a mechanism which will satisfy all of these properties, but we had some data available with us. So we said, why not use this data and use a deep learning algorithm to design a mechanism which will satisfy these properties to the best possible extent. Fine. And this is where deep learning came into picture. So you started with optimization, then you went to game theory and mechanism design, you are now also trying to use a deep learning, and by designing a deep learning network which will do the allocation for you and which will also determine the prices for the auction, you are actually able to get a mechanism which will minimize the total cost of procurement, satisfying all the other constraints that I had also stated, right? And then we tried to sell this idea to the FPOs. We tried to sell this idea to the vendors, coming to the practical implementation. And then we have to also sell this idea to the farmers, right? We have a beautiful algorithm which will work, right? And we have a mobile app which, Bharat Electronics Limited has already designed. Now the question of deploying this mobile app. So we went to Anekal FPO, we went to Rajkhata FPO, and then we were faced with many challenges. So there are challenges in practical deployment. Progressive farmers are convinced, but not a typical farmer, right? So in farmers also there are progressive farmers, right? They're very happy with all of these. They want to try out technology. And in this case also we had progressive farmers. We were able to convince them very easily. Typical farmers are not convinced, even if you speak to them in their native language. I remember talking to a farmer and tell him, ಈ algorithm ನೀವು ಯೂಸ್ ಮಾಡಿದ್ರೆ ತುಂಬ ಚೆನ್ನಾಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. If you tell them, they will come back and tell you, ಸರ್ ಇವೆಲ್ಲ ವರ್ಕ್ ಆಗೋದಿಲ್ಲ, ನಮಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತು ಇವೆಲ್ಲ ವರ್ಕ್ ಆಗೋದಿಲ್ಲ. ನೀವೇನೋ ಹೇಳ್ತೀರಿ, ನಾವು 40-50 ವರ್ಷಗಳಿಂದ ನಾವು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಈ ನಿಮ್ಮ ಟೆಕ್ನಾಲಜಿ ಏನೂ ವರ್ಕ್ ಆಗೋದಿಲ್ಲ. ನಾವು 40-50 ಇಯರ್ಸಿಂದ ನಾವು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ನಮ್ಮ ಕರ್ಮ ನಮ್ಮದು, ನಿಮ್ಮ ಕರ್ಮ ನಿಮ್ಮದು. This is what somebody will say. Then I went to Hindupur and tried to tell a farmer in Telugu, my mother tongue, right? Then the farmer said, sir, ఇవన్నీ పనిచేసేలేదు, మీరు ఊరికే మా పక్క ఎందుకు వస్తారు? 40-50 సంవత్సరాల నుంచి మేము చేస్తూ ఉన్నాము, మేము అదే కంటిన్యూ చేస్తాము, మీ కర్మ మీది, మా కర్మ మాది. So this is the kind of response that you would get from typical farmers. Not easy to convince the farmers at all. Okay, farmers are more worried about credit and insurance. For them, what is important is they want to get credit because they don't have cash, and they want insurance on the crops. And for that also, they don't have the kind of resources. And then need to convince the farmers as well as FPOs, right? FPOs are also not easy to convince. Government officers are also not easy to convince, right? Then of course from a technical viewpoint, now we have used deep learning and it is producing some good results, but we don't know whether it will produce these good results always. So explainability of these models is a big question mark. Then data is, as you know, extremely important. If you are trying to use machine learning and deep learning models, data is extremely important. And the kind of data that is available in agriculture is not to be trusted. Clean data is not available. It's available from multiple sources. There is heterogeneity. And finally, I think there is a major challenge for deployment in terms of intermediaries, supplier companies, dealers, nexus among stakeholders, lack of finance with FPOs. But I think in spite of that, we have been able to deploy our mobile apps in the Anekal FPO and also in the Rajkhata FPO. And this is, I would say, this is only the beginning of the show. But what this experiment has shown to us, that even with a modest effort of the kind that we put in this particular area, some things can be made to happen. Now, I was talking about the farming sector where you have almost like 12.5 crore small and marginal farmers. Even if there is an epsilon greater than 0 improvement, if you multiply that by 12.5 crores, it's going to be huge, huge benefit. So we must keep trying. And we should also try to surmount all the practical challenges that we may have in order to make this work, right? But then at the core of all of these lies this art of designing algorithms. We are actually able to think of these mobile apps because we are able to come up with some algorithms which are based on sound mathematical and analytical ideas, whether it's optimization or whether it is game theory or AI, ML, DL, and so on, right? They are the core of the mobile apps that you are developing. There is a backend, and that backend is completely driven by algorithms. And you can see that there can be extreme technical novelty in the way you design these algorithms. So that is where I think algorithms play an extremely important role, and that is where art of computing also will play an important role. And if you are able to actually leverage this for high impact applications like agriculture and public health, nothing like it. It's very important to do very esoteric blue sky theoretical computer science research, because it will have fantastic implications for the future. At the same time, it is also equally important to use the theory that is already developed in bringing up practical applications which will actually make a difference to a very large number of people. So with this, I will close, and I wanted to present a few more, but I think there may be some time for a few questions. I don't know how much time is there for questions. Okay, so I can take some questions and then we can close. Yeah.
Hello.
I think there is one question here. Yeah.
Sir, I was just curious that why the farmers were responding like that. So earlier, if I'm a farmer, then that means I am a knowledge worker. Like I know how to produce some kind of crop starting from the sowing to the harvesting. But don't you think right now, when an algorithm is coming or a superior technological knowledge is coming, the farmer feels that his role in the whole process is threatened? It can also happen, for example, the same situation can happen in the medical field. For example, if personalized medicines come in and pharmaceuticals companies take over, then the doctors might be also in the same situation as the farmer.
That is one of the other practical challenges that you have, because there are also these agri companies and so on, right? So they also have a big stake in the whole thing. But the central player here is the farmer. If the farmer is convinced that these things are going to be good for him, nobody can stop this.
But sir, the problem is who is the central control in the whole process? The farmer loses his know-how because the algorithm is going to do the
government has to play a big role in this. For example, farmer producer organizations, right? So currently do not have the kind of support. The government is trying to do its best. But if the government can mandate certain things and say that the farmers have to go through only an FPO, things will fall in place. Okay. That's one question.
Hello, sir.
Yes.
I'm Unnati. My question is like, as we know, most of the farmers are uneducated. Like, do you have an option like the language translation? Is everything on English in your app, or do you have regional languages?
The app that Bharat Electronics has made is in English as well as in Kannada. And fortunately, now making multilingual apps is not a problem at all, right? So English is not the preferred language. Local languages are the ones which have to be used. Yeah. I think there's.
So, fascinating algorithmic use, very, very nice. It seems pretty ripe for given my entrepreneurial life now, ripe for an investment to actually launch this as a startup of some kind. Any reason why you're not doing that?
Okay, so it turns out that India is very rich in terms of agri startups. There are almost like 7,000 agri startups in India right now. 2,000 of them are in Bangalore. So we have had the benefit of talking to some of the startups in making all this thing happen. Yeah.
So you plan to at some point?
I think, yes, I think agri-startup is always a good idea, but we have found that if we want to pursue the kind of work that we want to do, it is better to work with startups which are already there rather than spend all your energy in coming up with a fresh startup, right? There is a startup, for example, called Samunnati, right? And we have been trying to work very actively with them. There are some very well established startups. So it is better to stick to the kind of work that we are doing, but work with the startup ecosystem. For example, as a part of the NABARD project, all the algorithms that we designed and the mobile app specifications that we have made, right? We are supposed to actually transfer the technology to startups so that they can take on from there. Yeah.
Great. Thank you.
Sir, I have a question, a technical oriented question. Sir, the promise part which you have explained, what kind of data do you all look up to? Have you all come up with your own model or used an existing model? Could you please
yes,
elaborate on it?
Yes.
Thank you.
Unfortunately, I could not get into the data issues, right? There is plenty of data available on agriculture in India. This data is the price data for all the crops in all the mandis in India. And there is what is called AG MarkNet, right? And there is also data available on, of course, climate, soil conditions, all kinds of different things. But one difficulty with the available data is that it is not clean. It is not even complete. So much of our effort has been spent in cleaning up this data and coming up with curated data sets. So when we release AgriVahan as a platform, we also have this idea of releasing some curated data sets with which different groups actually can work on. Right. So data is the key. Yeah.
No question from that side where when the person
So you
around for 2 days, so please make sure to catch him when he's free in a break. So maybe one question there, one question here, and we'll call it a session. Whoever has the mic gets
Yeah.
the preference.
so I'm here.
Yes.
So regarding the data sets that you had mentioned, so it was also mentioned that you have multiple sources, right? So you go and talk to the farmers and they tell you about the experience. Do you add that as well? Do you include the live data?
We can add that.
collection
Sure.
as
You can always add that, but the volume of data that you can collect in this fashion is going to be very limited.
Right.
You already have a huge volume of data available to you.
So
You can
from
actually
where do you
leverage this
take
data,
it?
and you can always add all this data, right, to whatever data you have.
So the volume
Doing field studies and collecting field data turns out to be a fairly expensive and
Yes.
time-consuming process
Yes,
in
definitely.
agri. So try to leverage as much as possible the data which is already available.
So do you take it from like surveys, or how do you like the data which you already have? What were your methods of collecting them?
Okay, the data is already available in standard government
All right.
from
Okay.
standard government portals, but
Okay.
it requires a lot of cleaning and curation. Yeah. Yeah.
Thank you so much. I think this was a wonderful talk. I have a slightly technical question. You started the talk under the hood of uncertainty. So typically in statistics literature, you have aleatory uncertainty and epistemic uncertainty. Aleatory comes from the fact where you have uncertainty in the inputs, and epistemic is something that is inherent into the system and
Yes.
not much can be done about it, right? So in this particular framework, which one you found to be more dominant? And
I would say the more prominent is the uncertainty of the ecosystem itself, right?
The
For example, the weather
epistemic one.
conditions, the climate conditions, and also market conditions, and so on.
But those are all inputs to your framework, right?
They are all inputs to our framework,
Okay.
right? And whereas for example, rainfall itself is a huge uncertainty. The other uncertainty that we were confronted with, the uncertainty in the data, meaning the data itself, the data that is available to you itself, right, is not reliable kind of data. So that's a different kind of uncertainty that you have to deal with. Right? But I think the uncertainty here is more external.
Largely from the input.
Yeah.
of this. Okay, thank you.
So great that we have many questions, but you can keep asking a couple more. as we set up for the next talk. Yeah, since you have the speech mic already.
Yeah, so like one last question, quick question here.
Sure.
So you talked about the lack of explainability in deep learning frameworks. So what kind of things would you have liked explainability for, and that would have helped you both convince the farmers and convince yourselves that your framework is working?
It's a very rich area. It's a very rich area. We have used deep learning or machine learning in many of our algorithms. And for example, if you look at the last application that I presented here, it is able to produce a mechanism which will satisfy all the properties that we wanted in to a good degree of approximation. But it's not clear to us why it is producing that solution. For example, if you try it out with some other input conditions, right, the mechanisms that you are able to obtain are not that great. And it requires enormous amount of hyperparameter optimization and then working with the architecture of the network in order to get the results that you want, right? So our understanding of why and how the algorithm works right now is very, very primitive. So I think it's a very rich area for further exploration.
Yeah, so let's take the remaining questions offline. Please ask Rahul from Walmart, who's sponsoring this event, to give a small token of appreciation to Nara.
Yes, it is.
Excellent. So after this great first talk by Professor Narari, let me introduce someone who, as I was saying, does belong to the academic tree. So our next speaker is Dr. Manisha Padala. She's currently a postdoctoral researcher with us at IISc. Manisha obtained her PhD from IIIT Hyderabad, working with Sujit Gurjar, who is Professor Narari's own PhD student. She finished her dissertation in 2023, and before that she completed her bachelor's BTech from IIT Jodhpur. Her research focuses on very interesting themes in fairness in AI, deep learning, and mechanism design. And today Manisha will be giving sort of an expository talk on deep learning, so of course you guys will be interested. So please join me in welcoming Manisha.
Thank you, Professor. Thank you for introducing me. So I'd like to thank Professor Siddharth and Professor Arindam for having me here, and I'm very happy to be here and talking about everybody's favorite topic, that's deep learning. And I assume a lot of you are familiar with what deep learning is. How many of you have already taken some courses or have done projects on deep learning? Oh, quite a few, quite a few of you. And how many of you think that it's going to take up your jobs? You're going to be left with no jobs because of deep learning. Oh, okay, you understood deep learning well. Very few hands have risen up. So yeah, I presume that you already know what deep learning is to a fair good bit of extent. And we do have these conversations about how deep learning is going to take over the world, or be the next big thing. So I'm not quite sure about what that if that is going to be true or not. But what I'm sure about is these conversations have become more common now than maybe 5 years back. So now we do talk about all of these things, and what made that possible is the fact that these models do show some good performance in terms of the learning that they do, and in terms of the algorithms that have been deployed based off deep learning. And today my focus will be on how on a little bit of a history of where deep learning has come about, and how it has been modeled based on the mind. So we all know that deep learning is very good, but let's see how good you are. So can you recognize who this is? Oh, so very good. So it seems you're already there. You're already the superhumans that we are trying to be, trying to make the models. So we are very good at recognizing images, faces, You are all probably, your minds are already all occupied in doing assignments and all of this and coming, so many parallel tasks that your mind is doing, and despite all of that, you're able to recognize images, and not just the image, just given a little bit of a hint of what that image looks like, you're able to identify what these images are. And oh, maybe the credit is more to Aishwarya Rai that you're able to recognize her. The other thing is, given symbols or numbers or all of these complex entities, our mind is it is very easy for our brain to recognize all of these, and we have not really, are we doing complex calculations in our mind to recognize all of this? It just happens very, very quickly. And how is that possible? It's a very, very amazing thing that our brain is able to do. And so the entire idea is try to learn what our brain does and try to mimic that in our code. So if you think about it, without, let's assume you forget about deep learning and everything, I'll just ask you, given all these images, and I'll tell you what these images are. I'll tell you that is a 0, this is a 1, this is the 2 different classes that these images belong to. I'll give you that information. Can you come up with a simple code to do that? Can you write a code for it? Based on, so if you think about it, these images are very complex, and it's very difficult to think of a starting point. How do I start writing a code for such a complex task? So it seems quite tough. But let's try to simplify this a bit. I'll just tell you, I'll give you 4 simple matrices. All of these matrices are very simple. They have 4 entries each and very limited numbers that they take, 0, 1, and -1. And I tell you, the first 2 matrices belong to a certain class A, and the second 2 matrices belong to a certain class B. Now I ask you, can you write a code given any of these matrices? Can you write a code to tell me which class does this belong to? Now it's fairly simple, right? All you have is 4 variables. Based on what these 4 variables are, the entries that they take, you can classify that as either A or either B. So this looks very nice. This looks fairly simple to deal with. Now let's level it up a bit. What if I give you very complex matrices? So these matrices are very large with lot of entries, and not just the entries, the kind of entries are also different. They take not just 2, 3 values, but a lot of different values potentially. So given these matrices, can you write a code to it? And I tell you what these matrices are. I'll assign some class to what these matrices are. You probably can already see a slight 3 and a 0 here. So they essentially are digits. So I'll tell you what these digits are, and now I'll want you to write a code to identify it. What would you probably do? You would probably look at all these number of rows and say, oh, in row number 4, there is a 36, 146, 254, etc. So this is most likely going to be a so-and-so number, and if it's, so looking at these patterns, you would probably write a one very long code saying, oh, because of these patterns and the way in which these numbers arise, these belong to certain class. So what essentially you're writing is a hard-coded pattern recognition sort of a algorithm wherein you look at all these patterns, but you're welcome to do this. So there is this large data set which is called MNIST data set, which has all these different kinds of handwritten digits. I'm pretty sure it's tough even for a human to specify, to recognize what these digits actually are. But if you look at all these numbers, all of these numbers will have a corresponding matrices and so many different kinds of patterns. And for each of these numbers, you'll have to write this very big code identifying what the pattern is in order to classify it. Very tedious. This is definitely not how your brain is. It doesn't seem like that's what we are doing. We are not doing a lot of computation just to identify some simple handwriting, right? So images are matrices. All of these images that you see in the world, they can be represented as matrices, which is good for codes. Codes, you can always write codes for write algorithms that works on these matrices. But still, there are so many different kinds of images with so many different characteristics that it's very tough for a computer to parse all of these images. But you are very good at it. You are able to do it very easily, very quickly, and you did not do a lot of learning. At least you did it long back, not anymore. So yeah, so what helped you learn it? what is the important thing? So the important thing, one that apparently all of us have, is the brain. So brain is the key component which helped you learn it. And it is important, looking at the characteristics and the ease with which you're able to do all of these tasks, brain does definitely have the computation or the power to be able to do at least such kind of tasks with a lot of ease. If I give you a very large algebraic, very large two numbers and ask you to multiply it, probably that is very tough for you to do it in few seconds unless you are Shakuntala Devi or something. But common tasks like image recognition or sentence completion, writing stuff, all of this we are able to do it with lot of ease. So brain does definitely have good amount of computation for that sort of resources. And what is brain? Brain is nothing but an interconnected network of neurons. It's just a lot of neurons connected together. More specifically, let's look at one very basic unit of two neurons, and these two neurons are connected together. Now, neurons are essentially, they essentially have two parts to it that we are interested in. The first part is these dendrites, the head of the neuron. If you see, there is this tree-like structures, which are the dendrites, which are responsible for receiving the information. What is information? Some sort of a signal. There is something called an action potential which travels across these neurons, and these dendrites have receptors to receive these action potentials. Now the action potentials travel through the axon, which is the connecting part of the neuron. It connects the dendrite, the head of the neuron, to the tail, which is the axon terminal. And now this action potential is going to travel to the tail of the neuron. And now comes the most important part that we are interested in terms of the models that we have nowadays, which is this synapse gap. That is where the entire computation happens, whether to transmit this signal to the next neuron, or do I not transmit, or this signal is not important enough for me, so I'm not going to transmit this. That is what each of these pairs of neurons decide based on some amount of information that they have been given. So this synapse gap, which connects the axon terminal and the dendrites of the next neuron, is what is very essential for us. So let's look at that in a little bit more detail. So here it's a crude diagram, it's a diagram that I have made. So this is a crude diagram of one axon terminal and one dendrite that is there, and I am trying to showcase the synapse gap. So what happens over here is that there are a lot of synaptic vessels which have neurotransmitters. Now all of these neurotransmitters must get released so that the receptors in the next neuron, the dendrite of the next neuron, receive the information. Now the idea is that if enough synaptic vessels go and fuse with the membrane of the ending of the axon, then only then will the neuron transmitters get released, and if there are enough receptors on the other side, they'll get these neuron transmitters, and the action potential, the yellow-red, is like the neuron has gotten fired up. So the action or the signal is going to move forward. But in the other case, if not a lot of synaptic vessels fuse with the membrane and there are not enough receptors for the same, then no action potential will be sent. So the signal is 0. The signal on the above case is 1, oh good, and the signal is 0 here. So now who decides how many synaptic vessels and how many receptors should be there? So that is the entire learning that the brain does. So based on the local information, some of the neurons will fire up, some of the neurons won't fire up, and that's how you're able to recognize or do the computation that you are able to do. That's the idea. So the number of vesicles and receptors will vary based on the local signals. So for example, if you look at a input image, this is this huge interconnection of neurons which are connected with each other in a very arbitrary fashion. And the moment you see all of these will sort of, some of the neurons will fire up. There will be a pattern to which they'll be firing up. So based on the kind of input that you get, the firing will change, and then you are able to decipher what it is that you are looking at and things like that. Now these neurons will definitely fire based on the neurotransmitters and the receptors that are there, which essentially are some sort of a weights or which is often called as the synaptic weights that is governing whether to fire the neuron or not. So that's the idea. And what you have is over 10 to the, think of ChatGPT and the largest model that is there, but in your brain, there are like 10 to the 11 neurons and each have 10 to the 4 synapses. So that's a very, very large model, and you have trained it quite well and quite quickly, in fact, based on the computation that happens. And so these many number of neurons help you do all the computation, and also they help you do it very quickly. So based on the model of the neural network that is there in the brain, McCullough-Pitts, this is the neuron model. This is the most simplified neuron model that had been given by these two scientists, Warren McCullough and Walter Pitts. They came up with this neuron model back in 1943, in fact. This is one of the simplest model that you could possibly think of. So what you have, the entire idea is based on these adaptive weights. How do you change these weights so that you get to the actual output that you want? So you have this input x1, x2, x3, x4, which you could think of as these matrix entries. You are giving these huge images or these matrix entries. You could fill in those matrix entries, and W1, W2, W3, W4, these are the weights or the parameters that you would want to adjust so that you get the required output Y. And in this basic unit of this basic neuron model, what it simply does is it simply multiplies each weight with each of these inputs and sums it up across all the inputs, and then adds additional bias to it. If the entire value of this sum of products is more than is a positive value, then you send a signal 1. If it's a negative, you send a signal 0. So there's no signal. So that's how you have modeled this very simple neuron model. But still there is a catch to it. We know the modeling, but if I tell you what the weights are, you can tell me what Y is. But in the real world, we know what X is and we know what Y is. The entire idea is to find the W. Can we find correct W's so that we are able to map the X's and Y's that are already out there, that we already know? Can we map the images with their corresponding classes? That's the idea. So the entire story of neural networks, or the history, is essentially to learn these weights, to learn different kinds of learning algorithms. And what is the learning algorithm that is actually that your brain is actually using is also something very interesting to look at. So in the first algorithm was probably proposed by Frank Rosenblatt. He's a psychologist, he's an American psychologist. Back in 1958, he was the first person to propose the perceptron learning algorithm, which is for binary classification using the very simple model of McCullough-Pitts neuron model. And he proposed this algorithm called the perceptron algorithm. And it sort of hyped interest into all these learning-based methods, which are very good at doing computation. Soon after, although, there is another American scientist, Marvin Minsky. During 1969, he wrote a book on perceptrons, and he attacked the algorithm that was proposed by Frank Rosenblatt, and he showed that this algorithm is not scalable, and also showed a lot of limitations to this approach, that is the perceptron learning. And because of that triggered, it's supposed to trigger this AI winter, wherein there was not much interest in this field of AI because of all the limitations that he talked about, and also not a lot of funding into this approach. But soon after, there was this one other very interesting, this is probably one of my favorite networks. These are very interesting networks by John Hopfield, which is the Hopfield nets. They are more complex than the simple model of the perceptron of McCullough-Pitts neuron model. These are Hopfield nets where there are multiple inputs and multiple nodes, and they are interconnected in maybe closer to how it is in the brain. And the weights are learned using this learning algorithm called the Hebbian learning algorithm, and it is inspired from how the brain actually does the learning. And in fact, on the contrary, so nowadays we have to feed in lots and lots of data to this network just to memorize one particular pattern. But surprisingly, for Hopfield nets, it'll memorize an image. Just with one image is sufficient for it to memorize the pattern that exists in this image. So this is more closer to how we do things. We don't need a lot of data. We are good to go with very, very few amounts of data. We are able to learn and see a lot of patterns. So what went wrong? So what went wrong is that the learning algorithm is not at all scalable. The capacity of these networks is very low. So these networks are more of like an associative memory kind of a networks where they try to help you retrieve images which look similar to the images that you feed it, as opposed to classification or regression or the kind of learning that you're familiar with. And on top of that, only 100, so I mean, if you have 100 neurons in Hopfield nets, it can at max memorize 15 patterns. So that's quite a very low capacity that we are talking about here. Which is why what is more celebrated is the 1986 paper wherein Rumelhart, Hinton, and Williams, they rediscovered this algorithm called backpropagation, which I'm assuming most of you have heard about it, which is what is used in the deep learning networks nowadays. So this is, and Hinton is one of the 3 Turing Award winners who have got award for deep learning in 2018. So they have come up with this very practical learning approach, which is backpropagation. It is, which is applicable to a very specific kind of a network that we call the feed-forward neural networks or the artificial neural networks nowadays. And it can be used for many, many different tasks. For example, images, videos, audio, text. You can convert all of them into some kind of matrices, some kind of representation, feed into this network wherein you want to learn the weights. And you could do recognition, prediction, recommendation, text completion. For all of these tasks, you can use this learning algorithm called backpropagation, and it does it for you. So that was proposed back in 1986, but not until 1999, where you got these GPUs and faster computations, was it more popularized. So they came up with this first network, the CNN, the convolution network called AlexNet, which was probably trained on a 3 GB system, and they could not train the simple 8-layered network on a 3 GB system, so they needed to use two GPUs to train a very simple 8-layered network back then. But that was one of the breaking points wherein, with more computation, backpropagation helped achieve really, really nice results. But still, for all of these different tasks, we need to train all these different models, very specific models. But what we have is just one brain, and it does it all, right? So there is still a lot of things to be done here. But here comes the next big break, which is the generative AI, generative learning. So this, I'm pretty sure, was never a part of its training data set. This is something that it has, these big leaders and Elon Musk, of course, playing holy, is something that this image has generated itself and imagined. And I asked it to generate a short poem on AI by William Wordsworth. So, and I'm not sure how many of you have read this poem, Daffodils. So it's almost similar to his poem Daffodils, but now it's on AI. Yeah, so now AI is able to probably imagine things. So generative AI is just, you have a one big model which is trained to predict itself. It's a non-supervised setting wherein it's trying to predict it's like the schooling process. It's trained on the entire public data set that is available. And here it's being schooled at. And with all these large language models now have 1.76 trillion parameters to be trained. They take months and months of training. So, and they have been fine-tuned for more specific tasks to give you better results. But is this it? Do they achieve it all? Do they do it all? Or have we completely bridged the gap between mind and machine? So yeah, so that's, I'm pretty sure all of you already know the answer. So we have to train these models on millions of data points, and they require months of training. And it is still not clear if they are really understanding the concepts, or they are just very good at memorizing, extremely good at memorizing things that they have been fed in. And of course, there are some very obvious stupid mistakes that deep learning does. So a school bus with a little added noise, which is not even perceivable, is now an ostrich. And there are these patterns for the deep learning network. These patterns are apparently some very well-defined objects like penguin, starfish, probably because of the patterns that it is able to see. So we need better models, we need better learning algorithms, and better hardware. All of these are something that we must look at. And of course, there are other issues to these deep learning models, like fairness and privacy issues that one must address. So this brings to the end of my talk, and these are probably very nice research potentials wherein you try to bridge so how good you are and you try to train all these models to be as good as you is something that you would want to research on and look at all of these issues that these models face. So yeah, that's something that is we welcome you all to do in future, to work on these models and come up with better learning methods. Yes, thank you.
Maybe time for 2 or 3 quick questions. We have a coffee break, so please, I think Manisha will be around, so you can
Yes.
ask her follow-up questions at coffee break, but maybe just 1 or 2 to sort of have a Maybe please give her 1 minute.
Hello. Hello.
Yes.
Yeah. So I'm a student from IIIT. I'm an external student from IIIT Hyderabad, and
Okay.
I'm working on deep learning and a lot of
I
other
see.
topics. So I just wanted to know your views on, do you whether believe in emergence of these deep learning models? So like to define emergence for the crowd, it's just if you linearly scale the amount of data and parameters in the model, it starts to have a phase transition where it understands concepts which you haven't told it explicitly to. So for example, understanding extreme complex mathematics, understanding things like that.
Yes.
So do you believe emergence will lead to a point that these models will start to get consciousness? They will start to have they will start to know whether they are actually AI, and that can cause actually a huge problem in their alignment going forward. So do you think that is possible, or that's just something of a fringe opinion?
Right. So I'm not sure if even I am sentient or not that way. That is a question even we can't answer for ourselves, let alone for these models. So yeah, it's a good question, but I feel there is a big gap between a model becoming sentient and model memorizing things. And before even we reach there are so many other milestones, like the simple mistakes and the simple issues that these models have, and we do not really understand anything about these models. So it's very tough to even predict what these models can potentially do in future. But emergencies like these are really something very great that is helpful to a lot of applications. They have given risen so many applications that we are able to use at such a scale. But consciousness is something that we need to really think of in a very different context. I feel it's not. Maybe is it enough? Is computation enough to go there, or do we need something more? Is something that we don't know yet, I feel.
Hi, thank you for your talk. What do you think about the symbolic approaches for AI? Because so far data and compute has worked well and we've seen progress, but conceptually it just leaves something to be, like it doesn't feel satisfactory. Like when we do math, we are not doing a pattern matching because we are finding a proof.
Sure.
That proof has to be fully certain.
Yes.
It's not really probabilistic.
Yes.
And there's always been this tension, right?
Yes.
Symbolic versus just have a simple multilayer neural network, throw lots of data, throw lots of compute, and it just works. So what's the future of symbolic AI?
I think it's two different threads. Of course, we need explainable models. We are not able to explain. Sorry, it's fine. We are not able to explain our own minds for sure, but we use it. We use it to a good capacity on a day-to-day basis, and we get benefits out of it. So we should use these models the way we can, without understanding till the extent we can, but it can only go so much. You need to know how these models work to be able to exploit it in a way that you would want it to be really useful to you. So these are, I think, a parallel set of processes that should independently happen and try to get to the best capacity that they can. Yeah, that's what I...
Maybe one final question. Break for coffee, and we start sharp at 11:50. But yeah, one final question.
Hello, ma'am.
Yes.
Ma'am, there's a book by Roger Penrose called Emperor's New Mind. It came out in the 90s.
Okay.
And the book tries to justify that we can't really reach AGI because we haven't really understood human consciousness in the first place.
Sure.
So do you think it is possible to reach the stage of AGI where AGI can actually become sentient without understanding human consciousness, because that's a mystery that's still to be solved.
Can you understand human consciousness? Is it something understandable? Is also a question that you need to ask. Is your mind able to, does it have enough, capacity to understand what consciousness is? Or is it just something that you can experience and, probably you cannot transfer something like that to a model, for example.
So
That's
in
of
the
course
book-
is my opinion. But
So in the book, he argues that it's very
sure.
Next time we'll
We
have
can.
a workshop on spirituality, computer science, and reserve it for that. But yeah, let's thank both the speakers. I'll ask Green Ravan to give
Thank you. Thank you very much. Thank you.
good coffee, tardiness, 11:50, we start again. Are you around?
Hello. Hello. Signal.
It's coming.
To catch that signal, it will take 5
No,
seconds.
who will be speaking?
This person.
You ask hit mic, you want hit mic, or will be asked first? Hit mic or
Yeah. Cool, right? Yeah, now I feel good. Anyway, okay, something like that. Yes. I don't know, should I start? Yeah, so the coming session will be delivered by George Mathin, aka Apupen. Apupen is a comics artist and graphic novelist. Yeah, he's very famous comics artist from India actually. And recently he wrote a book in collaboration with Laurent Dodin. Laurent is a French physicist, CEO of a AI company. It's called Light On. They work in language. And they published a book recently, it's called Dream Machine. So you can see the image here. And the Dream Machine was initially published in French. Then so far it has been translated in 4 languages. And the English version is here. And it has been distributed and published by MIT Press. So next session is by Apupen, but before he starts his talk, so we'll take the opportunity to launch the book here. So the book has been launched already, but this is just to show you that book is here, the cover, and book is getting, this book is selling outside also, so that you can buy the book. So I'll invite Arindam on stage so that we can launch the book, and also Appu, please come on the stage. Yeah, so one book, one. Yeah. Yeah, please, you come in the middle. You're that. Okay, okay. So this is the book. Yeah, we'll take just one moment. Thank you so much. So, Appu, stage is yours. You start your talk. But yeah, so we'd love to hear like your experience with collaborating with Laurent. And since we know like you're an artist, not a scientist, so how did you learn all this complex stuff and how you translated that complex thing into a comics form? That would be very interesting things to know from you. Okay, so yeah, so we are just waiting for your talk. Thank you.
You
I think I can go with this. Yeah. All right. Well, I've been making comics since 2005. Say, I call myself Apupen, and generally the books have been about a lot of issues, environmental. I studied economics and commerce, and I did some advertising. So that gave me a good backing as to what I wanted to say. And then I went and started working in the NGO world for a bit. I worked with Greenpeace, and I worked with a bunch of NGOs. And I thought I was seeing the same pattern everywhere. That's when I came to making books and making some stories. I want to start the session with something else, just to throw you guys off, because there's a lot of science and there's a lot of technical stuff and all that. But I want to look at it from an artistic point of view to start with. After that, we'll go into the book and the more technical stuff, I promise. But this is where I came from, in the sense, this is a book I made, this is a piece I made in 2008. It was part of my first book called Moonward. And from there, the editors, publishers in Chennai bluffed. They were smart enough to tell me that this piece is not fitting in the book, so leave it out. Let's do this later. I was a little irritated, but I took their advice anyway. And it was the right thing to do, because 3 years later, it grew into another book of its own. So I'm just going to play a 2-minute video first. After that, we'll go into the book stuff. Thank you. Just to give you a perspective of how I see it from the advertising world, we've been openly lying for large companies and making you believe that if you don't possess a certain kind of thing, you won't get laid or you won't have a happy life or anything like that. We're very good at that. I've been doing that for a while. Actually, that sustains me because the books really don't. It's a myth that books make a lot of money and all that. The people who write the books don't really discuss it. They don't tell each other like how much money they make. Mostly they have money at home or something, I think. So a lot of people who come into comics especially are very disappointed after their first comic. You know, it's like they spent like a year and a half or 2 years of their life making it, and there's nothing to show, and you go into advertising or something and you do like 1 or 2 months of work and there's more money. So why would you do this nonsense? So, well, yeah, I don't have a logic of why, but I'm trying to prove something with the work. So let's see. This book, I was at a residency in France at a place called Angoulême. Angoulême is a very reputed place for comics. They have a huge comic festival there. Most of the great comic artists, comic books that you've seen have won an award at Angoulême. And so I also went for the festival, and I thought, okay, a residency over there would like, you know, make something out of this nothing. So I went there and spent about 7 months like doing this thing. There was no support from the residency place, and I had trouble even finding contacts. So I had never spent so much money on myself. So I was feeling like a piece of shit. So I went around trying to connect with people over there and seeing what other work I could like pick up or do over there. And through another friend called David, and the Institut Français was very helpful in setting up like different small workshops and stuff for me to do around France. And I met this guy called David, and through David, I landed in Paris for an event, and I found like this scientist guy who was into AI, I heard. To be frank, like, I feel very awkward when I'm in France because of the way I dress or something, because the French people, they look like they were born into their clothes and all. So I hung out with the guy who looked like the second worst dressed guy in the house probably, so that I don't get noticed too much, and that happened to be the AI scientist guy, and we made a conversation, and I asked him if first, he was the first guy who was openly talking about the amount of resources it takes and the amount of like energy that we need. And he said, if we go on like this, we might run out of resources. We are depending on better batteries and better technology to take us through this race. What? So I at it from a different point of view, and so this struck me as very important and very honest, which a lot of my IT friends in Bangalore do not talk about. The answer is always more tech will solve the bad tech, much like Nandan Nilekani, who is probably a hero of many people. I have a little more like reserved approach to it. So I would rather have things tested and tried before you impose it on an unsuspecting population and drop them out of various records and like render them lifeless. So this guy's perspective kind of interested me, and I asked him if he want to work with me on a book explaining AI. Initially it was meant to be just a technical like thingy where he gives all the technical stuff and I write in the form of a story, and I do the drawing also. But slowly it grew, and we found interest in a French publisher first. So that means my writing had to be translated. So Laurent agreed to like translate it, and he and his wife actually, they thought translation was like no big deal. But after like 6 weeks, he was complaining. His wife was like pissed off. But well, they did it anyway. The book took a while. The contract took a while from the initial stages, but I was waiting for the contract to get done. From the contract to like putting out, it was like 5 months of mayhem where I had to write the stuff, send it to him. He checks all the tech stuff. First time working on like his teaching modules, which I don't know myself. So I thought if I can process it and put it down, it should be easy for a general public to access it, because I'm at that level of learning on AI, not like you guys. So I sort of tried to like catch up to it, and I asked him a lot of uncomfortable questions. He is a CEO of a company, and there is a little bit of the protective behavior that corporations have towards their products and AI in general. Like, people don't like to criticize. So in advertising, we have a lot of double speak. We say a lot of things that soften the edge, you know, like when we say it's dangerous or we say like, you know, people are going to get fucked and like run out of jobs. Instead, we'll say job markets will be affected worldwide. And that's how the corporate language goes. And I'm very used to it in my advertising scene. So I was pretty cautious about it, and had to wrestle a bit, but he's a good guy, and one of the, I don't collaborate with many people, so this was sort of a risky thing, but it was great. Like he's a if I can logically explain to him, he argues like a scientist, not like one of my friends or something. So if I can prove to him why I'm saying certain things, then we get through. So there was a point in between where he would take the piss out of my sentences, like AI is going to like screw things up for people. Then he'll add, if things remain the same and we don't come up with better technology and like the climatic conditions and blah, 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 blah. So the sentence, the punch of the thing is gone. In advertising, if you see, we have a headline, a simple headline. It could be a lie also, but we catch you with that. And that's the kind of thing that is that drives the point, rather. So we had a few things about that. And then I realized that there are many places in the book where we say AI is good. And to be fair, like, I'm not against AI or anything. I think it's good. I think it can be like great, but I'm just worried about the frantic pace at which it is being pushed down everybody's throat. Like, AI, they say it makes people's life convenient. Like, for whom and at what cost? Just ask those kind of things. I'm not looking at it like a profit-making thing, because I don't have a stake in it. But just as a citizen, when I look at it, and as an artist, when I look at it, there are many angles to it. So I said, okay, Laurent, like, there are many cases where we say AI is going to make great progress and this and that and everything. Where is the proof for that? Like, we don't have any proof for that. So then he thought, okay, cool, makes sense. So that's how we got to like a common ground of like saying different things about AI. And I think we had a great time like dribbling this, passing this back and forth and like making the narrative first. And then I got down to the drawing. We had the publishers asking us if we can make it a dystopian thriller sort of thing, which could be a Hollywood movie. And with so much information, it's not going to go that way. We had to make it more like a serious French movie or a European movie sort of thing. It can't go into the Michael Bay territory. So we kept it in a balance like that. The art had to be fairly real for you to take the topic seriously. It's the language. Like if I make it very cartoony, then you think it's a joke. If I make it like dark, then you think it's some like horror thing or a monster kind of like end of the world thing. It's not. It's very real. We talk about our protagonist Hugo and his wife, which is loosely based on Laurent and not his wife, but because he teaches, he's a CEO of a company, and he's got this startup thing going, and he's also a scientist. So this gives me enough perspective to talk about AI in many levels. And then I make a cameo and like do the other parts that we left out. That's the kind of thing we go through, so I won't bore you with that. Let's just see. That's what the book looks like. My fascination with artificial intelligence technology started very early. There was nothing magical in my fantasy world. Everything was made of parts, science and research. Everything was possible with technology, but back when I dived into a life of science. So that's how we start. He's in his optimistic super Hugo avatar. That's how he starts the book, because he's actually had a great meeting, and his company has been offered this amazing deal. And he's just walking back from that meeting, and he's thinking like, man, I made it, like, like I'm gonna get all this stuff, like I'm gonna sell and make like $1 million, and like I'm gonna move to a bigger flat, and I'm gonna get a bigger car and things like that. It needed time and the work of many brilliant minds, like talking about the past. But today, I get that same feeling I had 30 years ago. 30 years ago is probably when he came out of college, and that time the world looked very different. Anything is possible, and people are saying, look, it's Super Hugo. So he feels like top of the world, basically. It is, after all, springtime in AI land. There are new seeds sprouting everywhere. There are ideas that have waited through long winters for the right condition to roll out. So now we're in the garden in France, Jardin du Planté. So it's a garden where we used to take walks and talk about this stuff. It's between his house and his office, so it's a convenient place for us to meet and talk. Some of them have already matured into entire AI ecosystems. So I'm just playing with the garden and the seed and all that. It is the time to catch the sun and grow. My firm clay is all set to break new ground today. So this is the point where Super Hugo transitions into regular Hugo. That's why that frame in the middle is very real. So to show that it's a real place, and from there we get into Hugo's life. This is not the next page from there. This is in between. So I'd like to just see, Argo, do you want to come up, or like do I just like go on showing these things? All right. So yeah, he generally asked me like how this collaboration took place, and I told you about like the scientist and the artist getting together. It's kind of learning for me also. But yeah, sure, I learned a lot, especially about AI in the beginning, because like everybody, I figured I was also scared about AI, but I did not really know what it was. So the initial idea of the book was to inform people about what's going on. So it gets a little technical in between, which may not be much for you guys, but like I think it's kind of decent to explain to regular folk what's going on. You need to have an informed idea of a topic before you make an opinion. Simple as that. So now I think we are relying on a lot of information generated by profit-making companies that is ruling the roost right now. Even one discussion I had with some friends recently, when I asked them, they were kind of surprised how they find AI so friendly now. So that's a very slow process of like making these little playful things of AI for you. What we are playing with, all this generative stuff, all this text and images and stuff like that, it's just on the surface. It's the surface of this AI that you're like allowed to play with. I'm saying, I think one of the big cautionary things for me is that people are not separating the technology or the science from the capitalist influence and the commercial aspect of it. This is probably a case where we're being fed this straight from the profit maker's mouth. So part of the book we go into, he has an academic background, so there are friends who stayed on in academia, and there are others who moved on into the corporate world as well. So there's a little bit of like up and down between them about like, you know, no money for like academia stuff and like too much money on the other side and stuff like that. But point being, these guys say that right now the machines are so huge, what we need for training, what we have been training, that it can barely be afforded by a lot of countries itself. So only the largest like companies, which, or maybe, you know, China and like some part of US with some company, can afford the largest machines around. So that changes the direction in which this progress is taking place. Because usually you'll have individual researchers or colleges or government setups, laboratories where independent research is going on about different new things that are coming out. Here we have a scenario where you can have like independent research, but most of the strings are held by really large corporations, and there is a unfair focus, I would say, on the profit part of it rather than the cultural side or, well, the social side and how it might be useful for people in general. It looks to me like we don't care, in the name of convenience, to drop a lot of people by the side and go on and say like, you know, we want self-driving cars or better suggestions on our video feeds and things like that. Because when I really wait, like on the one side we have these automation like conveniences, and on the other side we have too much surveillance, we have gaps between the rich and the poor growing, the power and the powerless growing. It makes it a completely like commercial sort of thing with surveillance and control built in. it makes it a very easy tool for anybody who fancies a dictatorship or too much control of a country. It becomes very easy. So in the beginning, it'll be like it can run a whole company for you. It takes care of finance, it takes care of all the departments, HR and everything, and we'll get to the biases and all that later. But like, okay, this one I'd like to just go through. So now he's contemplating this deal. The company is called Real E, and really is like massive. And we have an Elon Musk kind of guy who's the head of this setup, and he's kind of like pressurizing Hugo to sign the deal because it's for a harmless little game. You get to this technology. What he does is with language stuff, and it goes into this larger package, which is a game, which is professed to be the future of what we do. So we all have these games and AI avatars that we have in the game, and we get points for like spending time with the avatar, because the avatar needs time to like train itself and get to know you as best as possible. It's not really clear what they're doing with the information in the beginning. So we have different characters, different like friends, whistleblowers coming in and giving pointers to Hugo as to like, you know, be careful, like check what these guys are up to. We heard this and that and all that, and slowly things get proven along the way of the book. It's a fantastic book, by the way. It's outside. If you haven't bought it, like, you know, please buy it and stuff. But okay, Immortality Games. What a time we live in. So that's a pitch. As an advertising person, if AI company comes to me, that's the first thing I'd pitch. Immortality. Don't say that you will be immortal. Say that when the technology is ready, this trained avatar model will be very instrumental in uploading your thoughts into this thing. Whenever the biological bodies are like fixed, we can like do that. And for that, it's a very crucial step. Just like, you know, how the government will tell you to like make some Aadhaar or something like that. Like, it's very important. I won't make it compulsory, but I'll just make it like difficult for you to like deal with life otherwise. So this immortality thing is like, it's a good pitch. Like, nobody wants to miss out on immortality, right? Like, when the technology comes, you want to live. So, you know, sign up for this, like play with this thing, get it to know you better, things like that. IDA, make a file on Really, Live Beyond, and related articles. And send a text to Anna, I'll make dinner tonight. He just had a little bit of a tiff with his wife, who did all her research online on AI and what's happening, and she found a lot of things that she's not comfortable with. So she had a little bit of a tiff at breakfast, okay? So I think it's an interesting part. It's the first time we bring that conflict in AI over there, right to his house. And then he's thinking about it, and he's like, yeah, she's right, you know, like, you know, ping, a reminder about a gift for Anna. Today is the 15th anniversary of, remind me later. So this AI assistant is there with him. Ida, I call, but it's for like, it's just a thing. It's a little thing that he carries, and it's his personal assistant kind of thing. And it keeps on reminding him about this 15th anniversary they have in the house. So it keeps coming in, like, you know, and then he says, shut up and all in between. It's just a thing for me. My students must deal with so much information. It's exciting to be on the cusp of a new age, but I'm not entirely sure how to equip them for tomorrow. This is not just like his thing, it's me like feeling bad for the amount of information people have to deal with today. Like, it was much easier when I was in school or I was in college. Like, I had time to myself. I had time to like go and sit about and think about like ideas and stuff. I was in Bombay, I still had time, but then I came to Bangalore and then I had a lot of time. Like, in Bombay things were rushing, but I think it's after I came here and I got that time that all these stories and things and books started working for me. But nowadays, I see it's very difficult for people to sit and concentrate on one thing. Tarkovsky had said in an interview in 1976 or something, he was asked what is his advice to like youngsters, and he said youngsters should learn to spend time alone. That is even before all the cell phone and all came, so you should remember that. The systems have become so massive that only the biggest corporations can afford them today. That means universities, research institutes, and even most governments cannot afford these machines. That changes the direction of progress. This is just to show off my art. I think it's like quite cool, so I just showed it, and there's a lot of text. I'm gonna like go through. We're getting more and more info about this billionaire and what the thing is, the real intention behind like what they're trying to do, the game, things like that. Now we're going to Vancouver, where the NeurIPS conference is happening, and he starts getting memories of his college life, and you know the ideals and the goals when he started doing this thing, much like how the internet started. There was like this utopian kind of dream when it started, and then slowly it disappeared or it got taken over, and that's the kind of internet we're seeing today. And as somebody who's been seeing this, we say in this that AI is a powerful tool in the hands of a destructive species. I come from that thinking. I've been seeing that all around and from the advertising world as well. And that's the part of this whole thing that I am concerned about. It's the same thing that I've been concerned about earlier also in all my books. It's just that AI is the new topic or the new gimmick that you use to do the same thing, to like get control, to like get more powerful, whatever. Here I have found people who shared my dream back when progress in AI relied on the academic world. There is still much to hope for. That is us being nice in the book. We want to say it's hopeful. Given my own choice, I'll be a little more careful with that, but yeah. How about a gift again? Like, you know, goes on. This is where this artist friend of Hugo's comes for this literature festival in France, and we have this little presentation of how it is outside France in the other world. So we have a little bit about India over there, and I really had a tough time trying to convey the scale of things that we are talking about here as against what they're talking about in Europe. Here is a system that is like totally designed for a black and white kind of arrangement. You know, we have so much gray, and we're gonna go like nuts trying to like clean it up. Or there will be a lot of people caught in the gap, in the crossfire, whatever it is. So this is a friend of mine, really, who I was having a discussion. This friend had an interesting point on AI. He wants robots that clean sewers because such jobs are always done by people of the lowest caste. The caste usually dictates the jobs one can do. I'm doing a little bit of explaining, sorry for the foreign audience. So they are linked to it as long as the job exists. He says if the job is simply not there, they will be freed of this caste burden. That's a unique point because, like, you know, like the Western world is not thinking about these kind of things. I don't think they're thinking about a lot of things actually. The AI will have simple biases like us: sex, caste, race, religion, language. You guys all know about the biases and what happens when like that is put into HR or things like that. It will inherit the biases from the information it is fed. So if a firm does not hire lower caste people, the AI will understand that is a rule of recruitment. It will take time to address these issues. Mostly we will never address these issues, and that's my point here. That's assuming they want to fix it. We love our biases and we win elections on that, so no thank you. The AI world is in an inhuman rush too. It does not think of ethics, society, or the environment. Just to say, like, you know, now it's a catchphrase: ethical AI, regulations, responsible AI, and all that. It's kind of like in the early 2000s, like all the fossil fuel companies became green. Like they have these two cute leaves and like a little flower, and they say better, brighter future tomorrow and shit like that. This is what we do in advertising. I think AI is going through that phase right now, even with the tools that are given to you to play with. It's a nice softening exercise that is happening, where, you know, you just think of AI as friendly, and they are also spending like huge money on like movies. I forgot, you must have seen it. There's this movie where like US has banned AI, AI is living in the heavily populated parts of China and Asia and all that, and we are like living with these nice looking AI, like, you know, they're so like nice and like concerned about our kids and all that, and we're sharing the resources with those things, the robots, and the US and the first world seems to be against it, and they are the villains and all that. So there's a lot of like propaganda happening, I would say. By now we've come to, he's thinking of taking a day off, and he was going for a walk, because all this stuff is like getting too much and it's too fast, like, you know, it has to happen so fast so that nobody really has a clear idea. Even these people who are like big AI scientists, like working, I talk to them, they're all like amazed about the speed, and they can't keep up with anything. They don't know why this is like going so fast. Of course we know why it's going so fast. It's like, you know, we have to like reach that point, and we have to get a monopoly or something. That pace is my problem. That pace is completely being driven by the business interest. And you know, let's just take it easy and like take some time out. Like, you know, I'm okay. I'm having a nice life without AI, with the little bit of AI that I use already. Yes, it's on me. Okay, that's all the coffee shit and all that. As you know, sudden automation may lead to chaos in many parts of the world. Many who stand to gain from the transition period here have invested in really disaster capitalism, you know, shock doctrine and Naomi Klein and all that. This includes using and influencing the public in every way, from expressing personal opinions to toppling governments. Power will be further concentrated in fewer hands. An ideal toolbox for complete control with surveillance and deepfake propaganda. These ideas have moved from the realm of mere probabilities into actual possibilities today. You must consider that. This is the whistleblower telling Hugo, who's like all counting like his money, and like, you know, he's told his wife that we're going to get the bigger flat and everything. So and he believes in AI. He doesn't believe in this kind of like manipulation of AI, but he believes in the technology. He's lived all his life in it, and he's not going to like move from it. He is going to do it, but how to do it in the right way is his question. This is again this whole chapter in The Office, where we talk about LLMs and like how they have these things going on. And the whole chapter has this sort of eye watching them. You can see like a larger like thing in the frame. All the pages of that have this like invisible, anonymous eye watching them, because they're in office. And the implication is that the big company already has been spying on them and within their office, and it later turns out that it's with the little IDA AI model that he has with him. So they've kind of like hacked it, and they're using it to know what his decisions are, and pressurizing him on the side about like, you know, different things the company needs. So that kind of thing. Here we bring in Jacques Legrand. Jacques Legrand is the suave, beautiful, like business guy. There was this movie where they say like, you know, the devil doesn't come to you with like horns and a forked tail and like a spike in his hand and things like that. He'll be the most well-dressed, like most like well-behaved, like, you know, absolute stunning character that you can like run into, and he's going to corrode your values little by little. No, he's not going to like tell you to turn right away. He's going to like change you slowly, so you don't even realize. So Jacques is like that. Jacques is always asking about, hey, how's your wife? Like, she's so great. Like, you know, you're so lucky to have her. She's so lucky to have you. Things like that and all. You know, anyway, when I'm in a stressful situation, I try not to overthink, because these guys scientists know. In our business, we are doers, because there is not enough time to think or wait for proof. It's the opportunity that we must seize. Our competitors will pounce on it if we don't. And now with ChatGPT making news worldwide, this is the perfect opportunity. I say you must act like a businessman now and not a scientist. It will be good for Clay and Anna, like his wife. Like, you know. So, this kind of suave behavior even I have seen, like, you know, I get uneasy when I see this. It's like very patronizing, and it's like telling you, like, you know, that's the best way, you don't know anything. So previous pages he tells him, like, you know, as a scientist he's valued, And what he needs is that business edge, to like say enough of science and go into that, take that call when it's needed to, join us in the next level of business. Anyway, now Hugo has some time to think, and he has this, like, the city is good for walking, like I must say. Like, I'm not a fan of like living there, but I like these places to walk. And these places, it's just primarily because I like this space that I put it here, because we're kind of like getting to the end of it, where we are talking about education, we're talking about all the right things, ethical, responsible AI things. We still have to see where they go, but we've kind of made that kind of a mention at the end, that there are things you can do, ways we can take it forward, kind of thing. I won't like spoil it for you. This is after the book. We finished about 155 pages of the 150 pages of the book, and then I got this idea that, okay, we want to show what AI can do as well. So we're going to train AI with my drawings. We trained it with about 500-600 drawings of mine, and we asked it to draw the situations, which we also fed the story, obviously, and we suggested 5 scenarios after the book, which go into like various territories, the last one being a zombie apocalypse and stuff like that, because come on, it's AI, like we can do whatever shit we want. So this is where this game becomes like extremely successful, and everyone's on the game, and life is all about the game. So we asked for a few scenarios. Of course, you have to prompt many times. It's like irritating because it doesn't know what's good and bad, even in the art. Like, so one will be good and the next one has no connection to that. So, okay, I understand. We need to train it more and all that. One of the main things we talk about in the book is also that AI does not create, it reproduces. We can discuss about that, and that's probably why some of the US courts have said that you cannot copyright AI art. My simple example to you is for visuals, because I had to do it in a few of the design schools that we talked. I take 2 posters, half of each, and I put it together. This is this half, this is this half. If I divide it into 1,000,000 pixels, 1,000,000 posters, and I mix it up, and I make something and I show it you, you think it's original, but it's not. It's made of the little pixels that are from the other things. So it reproduces, it doesn't create. What is missing is the intuition. There is a whole speech which is written by Laurent in chapter 5 about the progress of technology and where we are at, and I thought that was like pretty cool, so I put it as it is, as he had written, because he's the expert on that. I think it sums it up very well, asking the question that, the scientific edge, the research is, like the thinking has always been driven by intuition. And does this AI have that? Can we trust it is another thing, but does it create anything? It lies a lot, it gives you shit, like, it makes up a lot of crap, it lies through its nose just to please you, but that is not intuition. That is like trying to please you from what it knows. But can it create a new thing, like a new idea which you haven't thought of? Not a combination of many things, not combining like Dali and Bruegel and calling it Dabru, whatever. That's not the thing. So yeah, you can read it. This is like what the art that AI created. Well, the best of it, we prompted so many times. We've written the prompts there. We've written all this, and you can see in the blue patch we said, add dramatic details, because it was like very boring in the beginning. So when we say like add dramatic details, we get these like extra things which I like in the book. This is towards the end. It may take your job, your identity, and your soul, but hey, it's fun. That's really advertising, not me. We kind of end the book with that. This is the cover, the spread, the whole thing. You'll see it and you won't forget it, because I am good at advertising. I didn't leave advertising because I sucked at it. I was kind of good. Like, they told me if you stay in advertising, you're gonna like not be an artist. Like, I was there in the time when advertising people were not slaves of advertising, and they could see it in perspective. I had like creative directors who looked at me and told me, you want to be an artist, you have to get out of advertising in a year, otherwise you lose your soul. I didn't know what they meant. Now I do, and I thank them. His name is Rajiv Raja, and the other guy is Ajit Verma. I always thank them for like having the foresight to say that to somebody who's come into advertising. I know so many people now who like think advertising is the bee's knees, it's the coolest thing you can do, because that's what they are like telling themselves, right? To like make sense of their own lives. So yeah, like nobody should look down on advertising. It's bullshit. So I have been lucky like that, and in many other places, many people who told me like valuable things. This is the French cover of this book. I don't like it. Don't you guys like the the Indian one better? Like this one? Huh? Like, I don't know. Like, I tried that, but they wanted this thing. It's so bland. And it's like, yeah, I don't like it. Okay, thanks. All right, that's all I have. And now we'll get into some questions and talking. I would like to invite Argava to the stage, please. Yeah, come and talk with me. No, no, it's necessary. I feel too alone over here, and we are going to have a conversation now. Where is your...
Just I wanted to ask you, like, we can share the mic. Oh, like, I guess, like, I'm very vocal, like, my voice is, well, like, it can reach to the end of the room, yeah. So, what I wanted to ask, really, like, it's moving, anyway. So, when you are imagining all the images, like, since I'm also an artist, like, I saw one picture you showed, like, one brain and some sort of wares are coming out, and other images, like Fugo, of course, like, is a character, and you already told that it's like you got inspired from Lauren, right? But other images, like since I've read the book already, other images, like how you are imagining, and when you are testing with AI, how they are imagining all the machine kind of part, like not the human part we know, or the you drew the all gardens you are walking around. That part we know, like it's kind of like universal in world, like the trees, the people, and the building. But the imaginary part, like where some kind of abstract thing you had to draw, because we do not know what the computer is doing inside. Like perhaps they are piling up some sort of image, they are trained, and I at least do not know how they are piling up. How you pile up, like how, when in your brain, how you process the image. Because like you are taking some image of brain and some sort of glass beaker and some sort of wire, and you are piling these things up to make a new machine or something, like how you do that. And like since we do not know how machine do that, so what is your take on that? That's the only question I wanted to ask.
Okay. Can you hear?
Now I
hear
can
me?
go there.
No, no, you have to be here and ask the next question. I'm going to take time.
People will ask, so I'm sure like people might have other questions. So yeah, so you answer my question first, because
can you hear me?
As an artist, this was my question.
Is this working? Is it coming through? No. Okay. Actually, yeah, good. Oh. He's cool. He's all right, guys. All right. Like I said, comics don't really pay the bills. So there's a lot of visualization of information that has become very interesting for me commercially as well. Because mostly what we need, comics or graphics, is to dumb down stuff to make stupid people understand what's going on. So I put that into my own like thinking here. I'm the stupid guy, and I need to like understand this thing, and I also need to look at it like a child. I need to look at it like I'm visualizing something that I don't know, and from the knowledge that's given to me. So there's a lot of stuff where I've had fun actually with the visualization. Just moving inside this unseen sort of world. There is no rule to it. It just has to make sense or help you get from point A to point B. There was a brilliant like presentation earlier where she was showing when she opened up the images to connect the synapses and the neurons. It became a lot more easy for me to like look at it also. I think it does the same kind of thing. We try and add the missing visual details just to visually connect it for you. The actual thing might not look anything like that, but there were many points, and I think that's the kind of new part I've added to this book, like in terms of like the art and the comic world and all that. There were a few reviews in France that talked about this visualization. I think people are finding it easier to understand this with the added visuals, with little jokes inside. You know, I need to be like pretty straightforward, so I can't throw too many jokes. But whatever I feel while I'm like drawing it or while the topic comes up, I have like added little bits here and there. But I think it's just where it is. So to show, I don't have the images to show, but show that it's an infinite world. Okay, so I can like put stars and everything, and I make this thing, and then there are connections, like, you know, things are happening, and then once this connection happens, this thing turns into something else. So yeah, slowly that thing is like changing in something, and then that gets connected to something else. It's kind of like a trip for me to like visualize these things, and also it was like the relief in the book, because we are going very straight and the information is very heavy. So it's the job of like simplifying that information and putting it down. In a way, this is what we do in our advertising thing as well. We think of like visuals that connect with the topic and make you buy something. Here, you know, you just buy the book, but like, I hope the visuals work in conveying the information and like making it simpler. Come on. For questions. Okay. Oh, we have a lot of questions. Hello.
Audience, and now there's a third player, right? The technologists which are saying creators actually have too much power, right? And we are gonna democratize the process of creation. How has your take on this evolved when the AI has arrived? Let's say Mid-Journey, or so Hollywood used to be the bad copyright people, and now the tech industry challenges Hollywood. How do you see this dynamic evolving?
It's interesting, because I'm looking at it the same way as I looked at it earlier. There's always these agendas that are being played out. This is just a new agenda for me. It doesn't directly, I was thinking about it, it doesn't directly threaten my comic making. I think, you know, an original art piece or an original thought, you can tell. I don't see it. I mean, there are enough comic creators. It could make something. It is selling books right now. It's making like books and selling it, I know. My publisher tells me that there are like AI generated books like doing the rounds, and that will happen. And maybe it's a blimp, like, I don't know, maybe it'll last forever. But I don't see that threatening me directly. But like I said, my income is more from advertising or brand identity and stuff like that, and I can see very easily how an AI model can be trained on all the existing brand identity things that are there, and you can prompt for a better one, and it will give you like 100 of them in like 5 seconds, and there I cannot compete. So I think it's going to like affect the art scene in those kind of ways initially. There are a lot of people playing with AI, not realizing that they are training the AI. In fact, like, you need those many people to like play with it to get it in shape, you know. So we are actually like doing that job. We're pretty much like what I used to do for Photoshop, I guess. Like, Photoshop was free, and you know, we were just working on free Photoshop for like some 12, 16 years or something before like it all became like licensed. So now I moved to Procreate on iPad, and it has most of the functions there. But like, yeah, and some hacks are there, so okay. But I see this like affecting all fields right now. And when, you know, every time we discuss it, it's like there are I don't know, the argument doesn't like, you know, you would be free to follow your passion. Like, that's the stuff the West likes to say, but like, tell that to somebody in India who's losing the job. You know, I was at the Madhurabhumi Lit Fest in Trivandrum last week, and there there was a discussion on, and there was somebody very like, there was almost like an argument over there, like very vocal and stuff. And that guy got up and he said like, see this watch, this was an invention at one point of time. And you know, are you saying that you will live without like using this watch? Like, you know, look at this. Everybody's using the. If we stopped and didn't use the watch, like where'll we be and all that? I wasn't part of the panel, but what went in my head is like, you know, this is a gun, and you know, I'm gonna come and blow your bloody brains out. But I won't do it just because there are rules and regulations and laws. You know, it is also an invention that we made, and we like put those regulations. Otherwise, your brains will be all over this place. So I have a tool now with which I can blow your whole family apart. I can take your job and like, you know, render your family like out on the streets. And I'm just saying that we need to be cautious, or we need to have like some kind of regulations on it. I'm pretty sure that like there will be regulations on a case-by-case basis, like the EU said, and that is going to take time because things are going to like come, and then you got to like run after it and figure it out. So we need to protect a bit of the workforce, I think. Another popular argument is that industrial revolution happened and things change and this is how we go. Sure, that took about 100 years and this is going to come overnight. So the displaced employment, the displaced workforce needs to be absorbed somewhere. So create some avenues for absorption and then do this. So it's not like against it, but like how to work with it. And there are many ways in which it's working great. There are some filmmaker friends who are doing some very sensible storyboarding with it. Of course, the storyboard artist has lost his job, but from the filmmaker's point of view, I worked with him. It's very easy. Like you can change angles and you can change lighting and like go all around in no time. Like I don't have to wait for the storyboard artist to come back and all. So in many cases, it is working, and if it's helping the overall project, and well, as long as the final film is not like fully made by AI, I mean, even if it is, I would accept it if it is good art. If it has a point, yeah, sure. I don't see it like that. I think it's just, you know, this craze about it, and we have to like get to this in like in 15 minutes. That should just like relax a little bit. I think that's all. Go on. Somebody else is here. You. Okay. Here.
Thank you. Well, I think the whole situation with AI is like, I like to think of it as a Pandora's box. It's been open. You can't shut it down. And while you did this work, you know, as a layperson who just started understanding AI, etc., I'm sure you've had discussions where I guess the short of it is, you know, we have this dystopian view right now, you know, which is very rampant. So what would be the utopian view, right? I mean, it's out there, you can put it back in, and we don't even know all the ways in which it's going to manifest itself. And, you know, and we don't even know what kind of regulations to put in place because, again, you know, the manifestation and it's going at this breakneck speed. What would be the alternative be, right? I mean, have you given any thought to how do we sort of control this or minimize the effect? Because I think that's what we need, right? You know, in the worst case, what are the guardrails? Have you, as a layperson, have you thought about that? I mean,
I think
I would like to hear that perspective.
Of course, we do suggest some of that at the end of the book as well. It's not to portray a dystopian picture of the whole technology. It's just I'm very tempted to, but I'm afraid of the utopian picture because that is being painted very well already. I don't want to be one more guy who's going to say that, you know, great things are going to come and end it at that. I would like to put up some warning signs, because I don't think this book or I am going to change the way it's going to go. This is the best I can do. It's pretty much like my political comics. You know, I put out a lot of political comics, but nothing's going to change, I know that. But, you know, at least there are some people who look at it or some warnings that we can put up. This is intended like that. I'm very tempted to do this utopian take, because something like Sultana's Dream, if you know that story. You can just check up Sultana's Dream. It's an old story. an animation is coming out like soon. Like so, that utopia uses technology in a very nice way. Simple. I don't think the profit interests or the commerce and the economics that I studied, the people who are like born in that, I don't think they see the thing the same way. In fact, while we were making this book, there was one of this discussion, one of the like crucial things in the discussion between me and Laurent was like, Laurent being a scientist, and a CEO. After some time, he was like, okay, like, there is no way Hugo is going to drop this deal. It doesn't make any sense. Like, and I do understand that that's how a business person would look at it. I do understand that is Laurent talking from his real status. There is no way that they are going to drop this deal and say that it's better for the world and like larger good and all that. No, he's going to take that deal and he's going to do it. That's exactly what I'm afraid of, and that's why I don't want to like give the rosy picture again, because they're going to take that anyway. So I had to convince him that you watch these movies, Laurent, like you know how this is. Like we have to put some values. We are talking about this hero, this protagonist character, and our readers have invested in this character. Now I'm talking purely from the story point of view. Like our readers have invested in this character and they would like to know that they invested in the right kind of character. They don't want to go through the book and finally, after he learns about all the problems that are possible, he says, yeah, screw all this shit, I'm going to like take this thing and like get rich. But that was the point. Like he was like, nobody's going to take this decision. And I know this because like, from the time like in 2000, 2001, 2002, I was working with Greenpeace, doing these environmental things as a joke. Like nobody like listens to anything. This is just like a little bunch of people like standing and shouting. Nobody even takes us seriously. We go to these HLL like AGMs and all, and I like walk down the aisle like holding banner, and Mr. SS Banga just like quietly like ignores me, and like they go on like doing their thing. Some security guys come and take you outside. Nothing really like happens, but I don't know. I think it's just like personal satisfaction or something to like just put up some signs. But you're right. Like if I wasn't scared of this excessive business interest in anything that is big now, I would really love to like do a utopian take on it, because how long are we going to sit and complain, And there are some like actually Huxley has gone into this territory, not exactly with AI, but utopian ideas of how societies can go together. The Sultana's Dream is also something like that, but it uses technology also, though it was written in like 1920s or something. So yeah, I like that.
Yeah, can you hear me?
After you buy my book, okay?
Yeah, so what you said is like take two parts of a picture, put them aside, put them in million pieces and like make them together, and it's not a new picture, it's taken into this. But don't you think as an artist that you take inspiration from things around you, regardless of whether it's knowingly or unknowingly? But don't you think like as a normal person also, the things you draw is being taken as an inspiration from something else? So how can you tell the same thing for AI?
Because I'm not cutting up a picture and putting it together. I'm thinking it from my mind.
But like still it's an inspiration, right? To some extent.
Yeah, and none of these artists, like I'm looking at a tree and I'm drawing it. But I draw it in my own way, right? I'm not like, it's not the tree. Like I can draw it in my own way, and if you draw that tree, it'll look different also. There is a lot of space in art. I mean, for the sake of argument, we can say that, yeah, our inspiration is also like technology, where we like take this in, and that's how all art is born. We've been doing that for like ages. But you see now this Rutkowski thing you must have heard, and Midjourney's like list of like artists it is training people on, you must have heard that it leaked.
Yeah.
It has all the famous artists, and they said like they don't expressly train them on famous artists, but it's there. Why did they say that they didn't, why were they defending it? And the artists that are to be used, you saw, it's got like MF Hussain and all in it. And these art pieces are owned by estates and the families of the artists. You have like gone online and you've scraped it online, and you're giving it for fun. For people like the Rutkowski guy, I'm not like a big fan of. He makes like Lord of the Rings kind of like fantasy dragons and castles and people with swords and things like that. Yeah, like a lot of people want to play with that image. They want like, you know, a donut in the sky with like in Rutkowski style. Rutkowski's like heartbroken. Rutkowski goes and he's like, no, you know, my art is being like misused. Okay, like, you know, his style has been studied and it's generating stuff. I don't think that's really fair. But on the writing side, I can write like any famous artist now in English. Like it's not yet reached the stage where I can do it in Malayalam or something, because we need that level of training. But we are again using that. And without rules, we'll use it, whether for fun or for deep fakes or whatever. But I think that copyright law is like a little bit of a thing to look for, because if you can't copyright it, then you can't sell it. You can do it for fun, no problem. But when you're selling it, it's the same thing I face with my editor. When I make a book or a story and I go to the editor will say, hey, this looks like this story and that story put together, we can't publish it. But it's up to me to use my influences and make a story that is original, right? So I think that's where it goes to. So if I can do that, then my editor will like accept it as an original story.
I mean, as technology like advances, things will take time. So that copyright law, which is a gray area right now for AI related stuff, will also take time, but it'll happen in time. Like as every new technology comes in, the laws and rules take time to, what do you say, to be put forward. But since it's like very gray right now, it's very new, it's in its you say baby step stages. If we start to criticize it right now and like stop it, then we wouldn't know what its full potential is.
Of course, we'll know many areas of full potential. We won't know the full potential of how much it can do with like images alone.
Yeah.
But it will be done like not for like profit making, like not for copywriting. You can do, there's no problem. Like we can experiment, but it only comes to the thing when that copyright or somebody else is in question. That's all.